In this video, you shall see a car waiting to make a left turn at a yellow light. When the driver feels that is safe to proceed, they begin to turn through the intersection. An oncoming vehicle also proceeds through the intersection, during a yellow light, and the two cars make contact. By Kentucky traffic laws, a vehicle making a left turn on a solid green traffic signal, not a green turn arrow, must yield to oncoming traffic. Therefore, the car making the left turn is listed at fault. This, however, can be contested, if the oncoming car was in the process of committing a traffic violation, such as speeding. The purpose of this video analysis is to determine the velocity of the vehicle running a yellow light and in turn, causing a car accident.
To determine the velocity of this vehicle, we will need some specific information about the year, make and model. This information was obtained from the police report. Given this information, we can look online to determine this vehicle's wheelbase, the distance between the front and rear tires. Record the point in time in which the front tire comes into view, red arrow, then advance the footage until the rear tire, black arrow, reaches the position of the front tire. The difference in time is the amount of time it took the vehicle to travel the length of its wheelbase. This velocity is in inches per second, which is easily converted to miles per hour. In this table, we can see the vehicle information obtained from the police report, physical details about the vehicle, and reference information about the video and area. From the time indexes indicating the position of the front tire, and the corresponding time index of when the rear tire reaches the same point, we can take the difference in time to get the elapsed time. Taking this elapsed time, and multiplying by the length of the vehicle's wheelbase, we can calculate the velocity of the vehicle in inches per second, and then easily convert that to mile per hour. From this graph, you can see, from the results calculated earlier, that the oncoming vehicle was, indeed, exceeding the posted speed limit of 45 miles per hour. Therefore, making the oncoming vehicle at fault for causing the accident. One thing that we cannot overlook is the video frame rate. As we have seen, from a previous slide, the posted video frame rate is 30 fps, frames per second. This calculates to each frame lasting 0.0333 seconds. Taking into account the slow frame rate, this means that our interpretation could be off by plus or minus 1 frame, or plus or minus 0.0333 seconds. Given this min-max tolerance condition, min-max vehicle speeds also shown. What if the oncoming car did not exceed the speed limit? Assuming that the oncoming vehicle was stopped by the previous traffic light, we can see the distance from the previous traffic light to the collision point is approximately 1,450 feet. If the difference in calculated time, between the posted speed limit and the average recorded speed, is around 1 second, this would be equivalent to 66 feet, or roughly 3 car lengths, before impacting. To calculate this distance and time, we will use several formulas. Given the published information about the performance characteristics of the oncoming car, we know that it can travel 0 to 60 miles per hour in 13.5 seconds and has braking capabilities of 70 miles per hour to 0 miles per hour in 169 feet. To calculate the acceleration of the vehicle, we can use the formula for acceleration. Rearranging the formula for time, t, we can calculate the time it takes to reach the posted speed limit, 45 miles per hour, and a vehicle's recorded average speed, 47 miles per hour. Now that we have the values for time, initial velocity, final velocity and acceleration, we can now complete our calculations for distance and time to reach speed, distance and time remaining to reach collision point. Here, we can see that if the oncoming vehicle was traveling at the speed limit of 45 miles per hour, there could have been an additional 1.18 seconds before impact, or approximately 78 feet, almost 4 car lengths. From the braking characteristics listed before, 70 miles per hour to 0 miles per hour in 169 feet, we can use the same formulas to calculate deceleration and braking distance. Since it would be incorrect to make the assumption that the oncoming vehicle was stopped at the previous light, we can only base our analysis from the reference point of where the vehicle came into view of the camera. Given the measured distance of approximately 202 feet, and the measured time of 2.5 seconds, we can calculate an average speed of 55 miles per hour. We can also calculate the time required to travel the same distance, if traveling at the speed limit of 45 miles per hour. Based on a speed of 45 miles per hour, the oncoming vehicle would make contact with the other vehicle in approximately 3 seconds, as opposed to the measured 2.5 seconds. Conclusion. Due to low video resolution and frame rate, the calculations for determining the oncoming vehicle's speed has a significant variability and cannot be accurately determined. Only basic calculations could be performed based upon the time the oncoming vehicle came into view and the time of the impact. Comparing the observed time elapsed to the calculated time, if the vehicle was traveling at the posted speed limit of 45 miles per hour, there is only half a second difference. It can be agreed that half a second of extra time would not have resulted in any other outcome, and the vehicles would still have impacted one another.